Hey folks, welcome to Shifting Policy Enforcement Left using GitOps. My name is Sundip and I work at Google Cloud. In this talk, I want to explain how policies and Kubernetes fit together with GitOps. We'll start with the basics around policies and policy management. Then I want to move into policy enforcement and how we can move that enforcement further to the left. Finally, I hope to share some resources to help y'all get started with policy enforcement. Now, at Google, my colleagues and I help teams adopt research-based DevOps tools and practices. And ultimately, our goal is to help software teams deliver software faster. You can find me at CRCSMNKY on Twitter and GitHub. That's Circus Monkey minus the vowels. So let's get started. And we'll start with some basics around policies and policy objects. Now, policies are rules that tell us how we can create, read, update, or delete a resource. In the case of Kubernetes, policies govern what sorts of objects can be created or updated. And the nice thing is that policies are granular enough where we can govern individual fields in an object, like the annotations on a deployment, or the names we give to our services, or the port naming conventions. So we have that level of really fine-grained control with these policies, with these rules. Now, policy management is something of a pretty broad umbrella term. It covers a lot of stuff. In this case, for this talk, it really means to cover how we create, administer, and enforce those policies. And it also kind of covers the mechanisms by which we sort of execute all these actions and all these functions. So let's start with the mechanisms. The most important piece to this whole equation is something called Open Policy Agent. OPA is part of the CNCF, and it is a general purpose policy engine. What do I mean by general purpose? Well, it can be integrated into a variety of applications and services, as well as platforms like Kubernetes. And it can actually be used for a wide range of use cases. Some of the popular ones we've seen are things like authorization controls, data exfil or data filtering, as well as admission control. OPA uses a high-level language called Rego to define policies. Now, Rego is kind of a new language. It's a simple language to follow, right? It's easy to do simple things, and it's possible to do complex things. With OPA, we get to design and implement policies that are separate from applications and infrastructure with kind of a loosely coupled approach. And in the sort of cloud-native approach to software that we're all talking about, we let applications and infrastructure evolve independently, and we can do the same thing with policies. And that's really what OPA gives us. It lets us have a loosely coupled approach to all these aspects. And policies can also bring in external data. Now, in the case of Kubernetes, that's especially powerful because that means we can compare incoming objects against existing objects within the cluster. So for example, if you wanted to write a policy that prevented someone from having a naming collision on services and enforcing some service name uniqueness, that's a policy we can write, but it requires external input, which is the existing set of services. So what's Gatekeeper then? Well, Gatekeeper is Open Policy Agent wrapped up and deployed as a Kubernetes operator and admission controller. The admission controller reads incoming objects and decides whether to approve or reject admission to the Kubernetes cluster. Gatekeeper also creates custom resource templates that wrap OPA policies, right? That wrap that Rego code into a Kubernetes object. And those templates, those objects, can be parameterized and deployed like you would any standard Kubernetes resource or Kubernetes object. So let me show you an example of that now. After installing Gatekeeper, Kubernetes now understands this first basic type called a constraint template. These are the templates that wrap OPA policies. So in the constraint template object, we include the Rego policy code. And now if you look at the bottom half of the slide, you'll see there's that Rego code specifically in there. And that code, what it's doing is there are 3 steps to that violation. The first is reviewing the kind of input type, making sure it's the type of service. The second aspect is checking to see if the service type is of node port. And if so, it sets that violation message and it throws the violation. That's it. The rest of the constraint template is essentially metadata. It tells us how we're going to use the constraint template. Now you can see the kind field highlighted, and that shows how these constraint templates extend the infrastructure to support new custom resources. Because what we'll do from here is we'll create another object based on that kind highlighted called a constraint, and that will let us enforce this policy. Now, I know I'm moving around quite a bit, so the question I usually get when I explain this is, why do we have 2 objects, constraints and constraint templates? And really, it's a pretty simple answer. It lets us separate the rule, which is the constraint template you see in front of you, from the enforcement of that rule. Because there could be examples where one template is enforced a number of different ways. So for example, within a particular namespace, we may want to force certain labels to be on particular objects. So that could be a constraint template that looks for a set of labels, and the way it's enforced through a constraint is different on a per namespace basis. So now let's take a look at a constraint. I think that'll help make it a little bit clearer. Now, in the top half, you have the constraint that matches up to our previous constraint template. And you can see the kind there is the kind that we created using the template. And on the bottom half of the slide, you see the sample resource we're going to test against. Now, constraints can be scoped to objects and or namespaces, depending on how you want to do it. And we can customize the enforcement as well. In this case, in this example, we've scoped this constraint only to services. Now that scoping, as I mentioned, could be expanded to any API group, to matching labels, to matching namespaces. You can structure the scoping, matching, and the queries pretty well. Now again, in this example, we've elected to deny admission to the cluster, as you can see with that enforcement action. So if the service object below tries to enter the cluster, it will not be admitted, because it violates our policy of disallowing any services with type node port. Now the enforcement here is set to deny, but we can also set it up to simply audit violations or provide immediate warnings. It all depends on how you would want to enforce policy violations. In some cases, it may be a gentle warning to a team that says, hey, your objects are out of compliance, you may want to start making these changes. Or it could be something where you have to shut the door as quickly as possible and not allow it to be admitted to the cluster. It really does depend on the use case you're trying to achieve with the policy violation. All right, so we talked about the basics of policy and some of the work around management. Now let's talk about the mechanics of policy enforcement. When does it happen and when should it happen? If we go back to our admission control example, you can see here that if an object violates the gatekeeper policy as it attempts to enter the cluster, it will be denied admission, right? We talked about that, so that's pretty straightforward. But, and this is the really important part, that denial happens when the object is deployed. So in that previous example with the service, we would only know that the service didn't get admitted to the cluster when we actually physically tried to deploy it. We would get that rejection right away. Well, what's so bad about that, right? We want to know that it's going to get rejected. It creates some challenges when we've got a GitOps type of setup, right? That runtime enforcement is not happening at the right time for us anymore. So imagine you have a Kubernetes cluster and you use GitOps to manage cluster infrastructure along with applications and services. If you have a Kubernetes object that violates any policies, like that service example we saw earlier, it won't sync to the cluster because the controller will try to synchronize it and the admission controller will reject it and it will fail. And now depending on your GitOps controller that you're using, it may keep trying and failing to sync that object. Or worse, depending on how it handles admission failures, it might be a different scenario. So it depends, right? If your GitOps controller is going to degrade gracefully, or if it's going to potentially block any other resources from that point forward from synchronizing to the cluster. Not a situation you want with trying to maintain, that tight relationship between repo and infrastructure. But that's not even the worst part. The person or team responsible for the violation might be totally out of the loop here, because this is happening at runtime or deploy time. They may have committed the change or approved that PR, and it's made it all the way to deployment, and now it takes time for the failure to happen, the failure to bubble up, someone to notice the failure and respond to it and handle it. And herein lies the problem, right? This is the ultimate issue. Policy enforcement is great. It's a really powerful tool to maintain, the right structure of our clusters and environments. But we need to bring some of that enforcement to happen earlier, or else the feedback loop is too long. And the downsides is that it could lead to some kind of unknown or unexpected cluster state. And this is what we're trying to avoid. Okay, we made it. Now let's talk about how to make policy enforcement happen earlier. Depending on how you and your teams develop and deliver software, you're either pushing commits directly to your GitOps synced repo, or you're using a pull request strategy, and PRs come in, they get reviewed, and the changes get merged into the sync repo. And frankly, that's two examples of, I'm sure, a dozen other different approaches that probably exist out there. But these are the two we see very often. Now, in either case, we can use those actions, code pushes or PRs, as the step where we validate changes against existing synced policies. Great. So now we know when to validate. How do we do it? That's where we start incorporating validation tooling. Now, here are two tools that really fit the bill for us. And the main requirement is we need those tools to allow us to run some sort of gatekeeper validation against arbitrary resources, and they need to allow us to specify policy inputs. Now, the first tool is something called kept. It lets you build workflows that work with configuration as data. Kept includes gatekeeper validation functionality out of the box as part of its standard library. So great, that's a great first step. Now, kept is interesting because it's incredibly opinionated and is really focused on resource configuration as the primary artifact. It doesn't rely on a templated approach or any kind of domain-specific language. It just always wants to maintain the final resource as the artifact itself. I'll be honest with you, the kept mental model can actually sound a little bit more complex than it is. I try to think of it as a simple workflow mechanism to process data or process configuration. So I can read some configuration in, I can apply some processing to it, like gatekeeper validation, and then I can kick it out to the next step. Comtest is similar, and it's part of OPA actually. It also lets you run policy validations, but in a more imperative manner. It effectively feels like more of just a standard CLI tool where you can give it some input and see how the validation works. Comtest is also general purpose in its own way though. It lets you validate against all manner of languages and configuration data. So for example, if you wanted to use Comtest to validate Terraform HCL, you could use it for that purpose. In our case, the Comtest approach we're going to use is validating Kubernetes objects against OPA policies. And that's a built-in approach with Comtest. So here's the first example, using GitHub Actions with Comtest. Now, on a code push, you can run this action on your GitHub repo that contains the push changes. They'll be tested against the existing policy objects. And now there are other actions out there that also use Comtest, but this one's from the original author, so I wanted to include it here. Generally speaking, GitHub Actions are pretty flexible. So updating this approach to work on a PR is certainly possible, or if you want to move it to a different stage of the process. Maybe you want to do it on a merge as opposed to the initial pull request. And again, while this example is focused on GitHub, you could develop a similar approach for any number of tools like the GitLab CI runner or Tekton you name it. But in this particular example, we can actually parameterize this GitHub action with a few options. The files we actually want to validate in particular, the directory of existing policies we want to validate against, and the namespace we may be testing under, right? Because in this case, you may not be testing in a live cluster scenario. You're just testing to make sure that the validations and the language constructs kind of match up. Now with kept, the order of operations is a little bit different. And that's mostly because it's a general purpose workflow mechanism. So first, you create a kept workflow, which is essentially a declaratively defined set of functions you're going to execute against some set of configuration data. And those functions either come from the kept standard library or other custom packages. And remember, the gatekeeper validation function, including all the other bits we need to read YAML in and process all that's part of the kept standard library. So that's great. It works out of the box. After you define all the function steps or all your workflow steps, you can export that workflow to a number of CI tools, which is very powerful. So in this example, I'm showing exporting to GitHub Actions, but you could also export to GitLab CI, Jenkins, Google Cloud Build, Circle CI, or Tekton. So it's a pretty flexible tool. And again, I think of this as a very general purpose workflow mechanism, even if it does feel a little bit hard to wrap your head around it. Now we've talked about some of the structure of when to execute this, but what about repositories? Well, remember we talked about incorporating the validation in that workflow at the repository level, but which repo do you run it on? Now, there's no right or wrong approach here, right? There's 1,000 different ways to do this, but generally speaking, we tend to see infrastructure objects like these sorts of OPA policies live in a specific infrastructure repo. And the other things that might live there are things like other controllers or other infrastructure-focused objects like network policies. In that setup, you would have a built-in validation workflow on that infrastructure repo, whether triggered by push or by PR. And that infrastructure repo is synced using your favorite GitOps controller to your Kubernetes clusters. So when a push comes in or a PR comes into this infrastructure repo, that validation workflow kicks off. Whether you use kept or whether you use conf test, you find out at that point, before that thing is synced to your clusters, you find out if it violates any policies that are right there in the cluster with it, or right there in the repo with it. My mistake. What about application repos, right? That's separate from infrastructure. So we tend to see app repos, whether they get delivered as Helm charts or otherwise, those are also synced directly using the same GitOps infrastructure. In this case, the validation workflow runs at the app repo level, but the first step of that validation workflow is to clone the policies from the infrastructure repo. That way, you're getting the latest stuff that's been synced to the clusters. So you know the policies that have made it to the clusters because they're in the repo, they were merged in or committed in, and they passed their validation step. And we pull those in as part of this app repo validation workflow. Because the policies may be written at the infrastructure level, but they still may correspond to application level objects like pods and services and deployments, jobs, you name it. So now we can make sure that these application changes are being validated against the infrastructure repo policies. When you get through all this, what you find is that with the policies in the cluster, we're protected against violations from imperative activities like kubectl commands or someone just editing a config live. But using these validation workflows, we're also protected against violations from getting committed to synced repos. So we've caught this problem and we moved it up much sooner, which is what we wanted. Now let's talk about how to create and test these policy objects. The Rego playground is a great place to start. In fact, I used it quite a bit to develop a bunch of the policies I've developed that are up on GitHub. Now, it's free and easy to use. It lets you provide some structured inputs, and it gives you a pretty good editor to work with, and it lets you share your code with other folks if you're trying to collaborate. But what I did find is that if you need complicated inputs, like a whole bunch of existing resources from within your cluster, or if you want to do any kind of in-cluster testing, it's only going to get you so far. So the next step is integrating OPA or Open Policy Agent into your favorite development environment as the next best step. Now, depending on your environment and the plugin support for it, you may have support for syntax highlighting, query evaluation, or even policy coverage. I think with VS Code and Sublime, I think have the most coverage in terms of capability, but you'd have to check and see how it is for your individual environment. Now, the nice thing is that this gives you a bit more control and flexibility on inputs and on testing, which is important, right? You want to be able to provide structured inputs so that you make sure you're testing and you're scoping correctly when you're defining policies, you're defining objects they're going to operate on. But don't forget, there is no substitute for testing against the real thing. And I know this because I did a lot of my work in the Rego playground, and there were just some subtle differences when I went to move into Gatekeeper and Kubernetes. So whether you can run Kubernetes locally or you can fire up a cluster, this is the best approach, right? Run Kubernetes, run OPA Gatekeeper, and try to push those changes in, right? Try it there. Also try out kept and conf test locally as well. You can incorporate and try out those workflows as well to see how the local validation is working compared to the kind of cluster level validation. The point of all this testing is that you really want to become as familiar as possible with the ways in which your approach might fail, the ways in which your policy might not catch all the scenarios you care about, or might not be structured appropriately, right? You want to understand all the different failure scenarios because you're writing security infrastructure. You've got to make sure it's bulletproof as much as possible. So now let's talk about some example policies. And I will tell you personally, no matter how many docs I read, examples were the thing that saved me time and again, because it was helpful to see how things worked when we were doing this work. So the first couple are direct from the Open Policy Agent project itself. As part of Gatekeeper, they include a number of getting started examples. And this lets you create constraint templates and constraints around things like requiring specific labels or which container image repos are allowed or not allowed, setting container limits and making sure those are included in your pod specs, or things like the unique service selector I talked about earlier. Now, if you go to the Gatekeeper library, that's actually an even bigger community-owned library of policy objects. It includes the general examples from above, but also others like forcing HTTPS-only connections, disallowed tags, setting unique ingress, and most importantly, it takes a bunch of the existing pod security policy approaches and re-implements them as constraints and constraint templates. So this is a great way to see how pod security policies are turned into these OPA and Gatekeeper objects and become part of admission control. Additionally, I've also written a number of Gatekeeper policies for Istio resources to enforce service mesh structure. And I've done that for open source Istio, as well as for our commercial distribution of Istio called Anthos Service Mesh. And in both those cases, I include things like enforcing MTLS activation or disallowing public access to your services, enforcing specific port naming conventions, authorization controls, or making sure MTLS is on for certain namespaces and services. So there are a lot of examples you can mine from if you're trying to build these policy objects. Now let's talk about the bigger picture for a second. When you think about running Gatekeeper, there is a lot more than just writing the policies. There is still some complexity around how you run the enforcement aspect as well. Part of that starts with how do you scope the enforcement? You've got to make sure you're focused on just the right resources, within the right namespaces, and maybe be using the appropriate correct labels to filter your objects down. Because you don't want your policies to be incredibly broad, right? That introduces potential failure scenarios. You want them to be as specific and narrowly focused as possible, and instead use things like multiple constraints to include too many types or different labels and different matching scenarios. You're better off having one good constraint template and a bunch of constraints to match what you want to enforce against. It also makes it easier to manage over time. You should also really get comfortable with the idea of failing open versus failing closed, right? This is the idea where if a violation is thrown, is your object still admitted or is it actually rejected from the cluster? And understanding that distinction, understanding that failure scenario is critically important because again, we're trying to create a security perimeter here and make sure bad things don't happen to our production environments. You also want to evaluate and understand how do you synchronize resources to Gatekeeper. So if you remember earlier, we talked about one of these policies being enforcing unique service naming setup. Well, in order to enforce unique service naming, we have to make sure that Gatekeeper can read all the existing services that are already in your cluster. In order to do so, you have to synchronize those services into the Gatekeeper namespace. So that's an important thing to be aware of as you're trying to build this. The more resources you want to cover, the more input that you might need means you have to synchronize stuff into that namespace appropriately. Again, just add some runtime complexity to be aware of. And then finally, who controls constraints and constraint templates? Right? There are RBAC controls that are really important to understand here because you want to make sure that only the right set of folks have access to enforcing rules or denying admission and writing those rules and those policies. Thinking even bigger, and if you take a step back, there's like a broader idea around shifting a lot of security stuff left, right? Bringing it earlier in our pipeline of development. We talked about policy enforcement obviously today, but there's a whole host of other aspects too, right? Things like signing your container images and then validating those signatures at deploy time to make sure that you're deploying only signed objects. Scanning containers for vulnerabilities to make sure you're not including anything that may be a potential security risk. Having fine-grained audit controls, or even encrypting container images. These are all really important aspects. And I'm just touching on them right now, but if you think of security in kind of cloud-native environments, we want to take a layered approach. And every layer adds a little bit more security and gives us a more secure platform that we build on top of. So these things, as we do more and more of them, as we incorporate them earlier in the life cycle of our planning and our products, we build a better set of layers around our infrastructure. Now, the last thing I want to close with is a tweet from Brian Grant, one of the original authors of Kubernetes itself. And I only include this because it was very timely. It was a few days ago. And he's talking about policy enforcement at multiple enforcement points. And I think this is really indicative of a trend and a shift where we're trying to get things that we know can happen at deploy time and at runtime to happen much sooner in our pipelines. Because it shortens that feedback loop, but it also gives us, again, that layered approach where we know if we didn't catch it here, we'll catch it over there. And that gives us good peace of mind as we start to think about how we scale these incredibly large and complicated production deployments. I thought it was great. It was just, again, very timely as I was thinking about putting together this talk. And so that's it for me. Questions, comments, concerns, I'd love to hear from you. Again, you can find me at CRCSMNKY. That's Circus Monkey minus the vowels on Twitter or GitHub. Hit me up. I'm happy to chat. I'd love to hear more about what you're working on and how it fits with policy enforcement. Thanks.